All right, this was the first question last year, or 2024, for their FRQ. You can tell this is a table question. So the temperature of a cup of coffee in T minutes is modeled above. So originally the temperature of the coffee is 100, and then as time goes by you can see it decreases from 0 to 12. The first question is, can you estimate the derivative of C at 5? So using a table, a derivative means you have to use average rate of change, or y2 minus y1, x2 minus x1. So you can tell 5 is not there. So what points surround 5? So the derivative would be the slope. So 69 take away 85 using the slope formula. And then 7 take away 3, order matters. And then the unit, we don't need to simplify that. But what would the unit be if I take the derivative? So I need to see the units. So it's degrees Celsius and minutes. So that's what it would be. It'd be degrees Celsius per minute. And that would be the rate. So you need both the y and the x coordinate to create that rate. Question number 2. It says use a left Riemann sum. Those are simple, right? With these intervals, and then there's a second part to it. So these are questions we definitely do not need to make a mistake on. So we're going to write down what we're doing. We're going to integrate from 0 to 12, c at t dt. And to integrate, we're going to do a left Riemann sum. So the first interval, the width of the rectangle goes 0 to 3. So that width is 3. And then we use the left height. So that's 100. And then we're going to follow that pattern across. So the next width is 4, and the left height is 85. And the next width is 5, and the left height is 69. We don't need to simplify that. Then the second part, it doesn't say anything about units or explain anything, so we're going to let it go. Then we're going to write down 1 divided by 12, 0 to 12, c at t dt. What does that mean? And that describes average value. So if you integrate and divide by the difference of the bounds, that's average value. So we're going to say that. What does it mean? So it means the average temperature in this story over the first 12 minutes. And you could also say the average temperature of the cup of coffee over the first 12 minutes. That's it. Number 3. It says from 12 to 20, that's past this table, the rate of change is given by this derivative. So instead of a table, they just give you an equation that describes the temperature, where that derivative is in degrees Celsius per minute. Find the temperature of the coffee at T equals 20 and show the steps of how you would do it. So the last temperature we know is here. At 12 minutes, the temperature was 55. So that's our starting value. So it was 55 degrees. And then I add and I integrate from that number 12 to what I'm looking for, which is 20. And I integrate the derivative. So there's the setup to show what you're doing. Then I want you to open up Desmos. If you need to press pause, press pause. Now, I'm not going to type in the derivative, so I'm just going to type in c at t and know that that is the derivative, because you wouldn't be able to type it in otherwise. So I'm just going to type that in. Make sure I type it in correctly. So negative 24.55 e to the exponent 0.01 t. I'm double checking my work. And then the denominator is t. Now I'm going to type that in. So it's 55 plus, I'm going to integrate from 12 to 20. I'm going to integrate that. And I'm going to write the answer down. So the answer is 40.329 degrees Celsius. Let me show my work. Part D. So I'm going 1, 2, 3. All of this is 1. That's A. This was, this here was B. And this here was C. Now we're at part D. In part D, it says we have a second derivative, and because it's a calculated question, I can just take the derivative of this derivative from 12 to 20. Determine whether the temperature of the coffee is changing at a decreasing or an increasing rate, and give a reason for your answer. So two things I'm looking for here. So first of all, I'm going to change this part up here, and I'm going to put it in from 12 to 20. So I'm going to go 12 to 20, and I'm going to look at the graph. So let me see that you can see this. So the graph actually is here. And so what I'm looking for in that graph is the derivative increasing or decreasing. So is this a rising derivative or a decreasing derivative? And because it's rising, it means that the temperature of the coffee is an increasing rate. Now, if I type in the second derivative, so if I go y equals, and I do the derivative of a derivative, so this is really the second derivative, what you could also notice there on the graph is this purple, which is the second derivative, is above the axes. It's positive from 12 to 20. That's also an indicator. So the first derivative is increasing, or the second derivative is positive. Both of those are indicators. So I'm going to write that down. So I'm just going to go with the second one. Since the second derivative is positive, and that's positive from 12 to 20, the question was determine whether the temperature, so we're going to say the temperature of the coffee is at an increasing rate. That's it. All right, we're going to do one question at a time. One video, one question. So Mr. G, math over now.